Assalamu alaikum dear friends. Today in this video we are going to find the length of the common tangent of two circles. You can see the two circles are given C1 and C2 whose common tangent is this AB, and we have to find out the length of this tangent. The radius of the circle is given as 9 centimeter, and another radius of another circle is 16 centimeter. Here radius of the smaller circle is 9 centimeter and the radius of the bigger circle is 16 centimeter, 16 units, sorry. Now we have to find out the length of the common tangent AB. How to find this? Before coming to the solution, let me introduce you with a theorem of the circles, which states that if we have a circle which has a tangent, suppose like this, suppose this circle and it has a tangent AB, AB is its tangent, and it's touching the circle at one point. We know the meaning of the tangent is actually tangent word is derived from the Greek word, Latin word tangere. Latin word tangere, which means to touch. Tangent, the meaning of the tangent is to touch. Now here we are going to learn another theorem of the circles, which states that tangent at any point to the circle is perpendicular to the radius to the point of contact. Here you can see it's a circle, suppose its center is C, and the AB tangent, this tangent AB is touching the circle at this point, A point, and it's making an angle with the radius of the circle. This theorem states that, theorem 9.1, perhaps you can find it in the class 10th mathematics as the theorem 9.1. the tangent is making angle of 90 degree with the radius of the circle. Here you can see the tangent is touching the two circles at point A and point B, and we have to find the length of the tangent AB. Only the things are given as radii of the circles. Here the circle C1 has radius 9 units and circle C2 has radius 16 units. Now how to find the length of the tangent? Let's start. Suppose that we are going to connect or join the centers of, suppose it has a center C1, O dash and O. O dash and O are the two centers of the circle, O dash for the bigger circle or C2 and O for the smaller circle or C1. Now you can find a quadrilateral is being formed here. This quadrilateral A B O dash O, this is the quadrilateral here we are getting. Now you already know that I introduced you with the theorem 9.1, or we can say the tangent theorem, tangent radius relationship. We can also say that here the tangent AB is touching the circle C1 at point A and circle C2 at point B. Now we can take this quadrilateral A B O dash O to another page. I will show you how to find the length of this tangent. Let's take here, suppose this is the circle C1 and this is the circle C2. These are touching each other at this point. These are touching to each other, and this is the tangent, common tangent to both of them. O, this is O dash, and here we are joining the centers of the two tangents. O dash is the line segment which is joining the two centers of the circles. The quadrilateral formed here has two right angles, because I mentioned already here that if we have a tangent to any circle which is touching it at one point, and the angle between the radius of the circle and the tangent is always 90 degree. Now here we can apply the same theorem. This quadrilateral OO-BA has two right angles, that is OOAB and O-BA. These are the two right angles. Here I will just draw the rough figure of this quadrilateral like this. Suppose this is A, this is B, this is O dash, and this is O. Now this angle is 90 degree, this angle is also 90 degree. This length, you can find this length, this O dash is equal to the sum of the two radii, that is R1 and R2. Here in this quadrilateral you can find the length of the side OO dash is R1 plus R2. This is the radius of the smaller circle and this is the radius of the bigger circle, and the radius of the smaller circle is 9 units and the radius of the bigger circle is 16 units. So total length of this side will be 9 plus 16 is equal to 25 units. Now let's draw the separate figure for the quadrilateral like this. Here we have the quadrilateral in this shape. This is the 90 degree angle and this one is also 90 degree. This side, this is suppose OO dash, this is 25 now. Here you can see OO dash is the sum of the two radii of the circles. The radius of this bigger C2 circle is 16 centimeter and the C1 circle is 9 centimeter. 9 plus 16 is equal to 25. Here this radius, this is the radius of the smaller circle. Suppose this is A, this is B, this is 9 and this side is 16 units. Now only side we have to find the length of is AB. Here we will draw a perpendicular. Draw perpendicular OD on side BO dash like this. This perpendicular makes an angle of 90 degree at point D with the side BO. Now we have here the two figures. One is the triangle ODO dash. This is the right angular triangle, a right angular triangle here, and a rectangle ABDO. We know that the rectangle has opposite sides equal. So if this side AB is the side of the rectangle and its opposite side is OD, that means AB is equal to OD. Now if we find the length of this side OD, that will be equal to AB. So we will find the length of the side OB and OD, and it will be equal to side AB. Here I will take the figure like this. Suppose now the figure became like this. This is A, this is B, this is D, and this is O, and this is O dash. This side is 25, this side is 9, again this side will be 9, and this side OB is total 16. Now if this O dash B is equal to 16, and it's the combination of two different line segments, that is BD and DO. It's equal to BD plus DO dash is equal to 16. Here the BD side is 9 because this is the opposite side of the rectangle. This is 9 and O dash D or DO dash will be equal to 16. So O dash D will be equal to 16 minus 9 because we have transposed 9 to RHS, and O dash D will be equal to 7 centimeter or 7 units. 7 units. Now this O dash D will be 7 units. Now we have here a triangle, right angular triangle here. Here is a right angular triangle. We have O, D, O dash. I will take the triangle to another page here. O, D, O dash. This is our right angular triangle, and its sides are, this is 7 units, this is 25 units, and we have to find OD, or length of the side OD, which is equal to the tangent, length of the tangent of the two circles. Here we will use the Pythagoras theorem, which states that square of hypotenuse, that is O dash whole square, is equal to OD whole square plus DO dash whole square. Now O dash is 25 square will be equal to OD square, we have to find this one, plus OD O dash square is 7 square. Square of 25 is 625, which is equal to OD square plus 7 multiplied by 7 will be 49. Here we can write OD square will be equal to, transposing 49 to LHS, we can get 625 minus 49. Here OD square will be equal to, subtracting 49 from 625, we will get 574. Now OD square will be equal to, 574 is the square of 24, so we can write here 24 square. Let's take the question to another page. Here OD square is equal to 625 minus 49. We can write OD square is equal to, this will be 574 576 576. Now OD square will be equal to, 576 is the perfect square of 24, so we can write 24 square. OD will be equal to, omitting square from left hand side, square root will get exist on the right hand side, 24 square. Square and the square root will get cancelled, OD will be 24. Previously we mentioned OD is equal to AB, because if you can see in the figure like this, suppose this is the, I will show you the first figure. Here you can see this OD, this OD is the opposite side of the rectangle, opposite side of AB of the rectangle OABD, and opposite sides of the rectangle are always equal. That's why I mentioned here OD is equal to AB, and the length of the tangent, common tangent is equal to 24 units.